Hello everyone, I am Masood and in this video I'll show you an efficient and quick way to solve 20 different math problems using the TI-36X Pro calculator, as you can see here. You will learn how to use it effectively to save time on the FE exam or other similar tests. Let's start with problem 1. Find linear regression based on the following data: 4, 5.5, 6, 8, and 9, 12, 14, 18. Imagine we have some point like these, and the problem asks us to find the line that best fits these points. For example, something like this line. To solve it with the calculator, the first step is to turn it on. Then we need to enter the value into the data button. So I will press data. So you can see some data here, but it is from my previous example, so we can easily delete them to put our new current data. Second column, we can delete them. Now I am going to enter our problem 1 data. 4, enter. 6, enter. 9, enter. 14, enter. So I'm going to second column to put the corresponding points data. 5.5, enter. 8, enter. 12, enter. And finally 18, enter. Now I'm going to press the second button. As you can see here, the regression options are here. So after pressing the second button, we need to press this button, and you can see some option here. We need to scroll down to find the proper one. So as you can see here, the number 4 is linear regression, x plus b. So press enter, and here we just need to confirm the data. For example, x data is in L1 column. We can press enter and confirm them as a default, and now I'm going to press enter to start the calc. So now you can see A equals 1.25 ax plus b, and b, so 1.25x plus 0.535. And if you have a look at the options, we will see the option C is the correct answer. So here, for demonstration purposes, I solved this example slowly to show you the process. But now let's see how quickly we can solve it again with a new set of points. Let's redesign the problem and solve it again. Consider points like 2, 4, and 5, for example, 8, 9, 11, 13, 18, and finally, for example, 15 and 19. I will follow the same process. So let's press data and delete the previous data, second column. So I am going to put the data 2, 5, 9, 13, 15. Second column 4, 8, 11, 18, 19. Second bottom number 4 for linear regression, enter, and AX 1.18, X plus 1.60. So this is the regression equation for these points. Let's move on to the next example. Example 2, find the area of region between fx equals minus x squared plus 8x minus 7 and gx equals x minus 1 bounded by intersection point. As you can see here, the intersection point of this line and this curve are point A and also point C. And also, as you know, the area between two curves or two equations is equal to the integral of fx minus gx. So we need to determine the integral of fx minus gx from this point and ending at this point. So let us write them: minus x squared plus 8x minus 7 minus x minus 1. So it should be minus x2 and 7x and minus 6. So to save time, let's use the calculator to determine the integral. So I am going to use the integral option of calculator. It should be from point A, starting from 1 and ending at 6. The equation is minus x squared plus 7x minus 6. Enter. As you can see, the answer is 20.8 and the option C should be the right answer. Let's go ahead to next example. Continue with examples 3 and 4. As you can see here, we have definite integrals that we can do by calculator, just like in the previous example. So let's start with first one. We need to enter the lower and upper limit in the calculator. So the lower one is 1 and the upper is 3. So now I am going to put the function. We can use a slash, but I prefer to use fraction bar, this button, for better control and visibility. X squared minus 1 over, we have to use the squared again, x squared, enter. So as you can see here, the answer is 5.3, so the option B can be the right answer. So we are going to put the second one. the same process. 1, 2, the function is x, e, so we have to put 3 times this button, exponent of 3, this button, and x. Enter. So here the right answer should be option C, 7.4. Let's continue with other examples. With example 5, which is about the probability. Example 5, in a firm 8 structural engineers are eligible for promotion, but only 3 spots are available. How many different combinations of promoted structural engineering are possible? This is a combination example. We have 8 engineers eligible promotion, but unfortunately 3 spots are available. Here the order of selection doesn't matter. I mean, let's say E1 as an engineer, number 1, 2, 3, 4, 5, 6, 7, and engineer number 8, and there is only 3 spots available. Let's say we are going to select 3 of them like this one. So when we selected E4, E5, E6, it doesn't matter if we say E5, E4, E6, and the order of these isn't important for us. I mean, the order of selection doesn't matter. So we can simply use the combination function on calculator, and we can use this button. You can see NCR and MPR, but the first function is factorial, and when we are going to use NCR, for example, we have to hit 2 times. So here the number of combination n is 8 and the number of r is 3. So I am going to put that, but we should notice when I click and hit 2 times, I see the n should be in the first, and it is going to select our previous answer as a n. So I am going to clear it, and the n should be 8. So I am going to click 8, and then I am going to select this one. So the r is equal to 3, and then enter, and the answer should be 56. And as you can see here, the option D should be the correct answer. 6. One person has forgotten his bicycle lock password. There are 4 letter places. The possible letters are 26 A to Z. If none of the letters is used more than once, how many different ways can letters be arranged to create a code? To be clear, I have explained more in the example. What is the maximum possible number of attempts for the owner to find the password? To solve this problem, we can use the formula for permutation, as the order of the letters plays a role in creating the code, unlike the previous example. Again, here also we can use the permutation function, as you can see here, of calculator, and let's do that. We need to press this button 3 times. So as you can see here, it is going to select previous answer as a n, but however we have a different n here. Our n should be 26, so I'm going to press clear and then I'm going to enter 26, then press 3 times this button to use MPR, and the R n is 26 and the R is 4 letter places, so the R should be 4, and we just need to press enter to have an answer. So if you check, the answer should be the option D, and that's it. Let's continue with examples 7, 8 and 9. Example 7. The following compressive strength data were obtained from laboratory experiment in a project. Units are in PSI. You can see the data here. What is most nearly the sample standard deviation of the data? So we can easily use our calculator. Let's do that. Data. And as you can see here, we have our previous data from example 1, if I am not mistaken, and we can easily delete them. Second column. Now I am going to put the new data. 150, 1, 2, so I am going to press second button, then statistics, REG, and I'm going to select the suitable option. We have actually one variable, so we can go ahead with number 2. We should confirm the data. My data is in L1 and we don't have any extra frequency, so I'm going to enter on calc to have a calculation. So as you can see here, the results are ready to use. The number of data is 7. X bar equals 3172. Sx equals 70.8. You know, X bar is sample mean and Sx is actually standard deviation. So here the question is about the sample standard deviation, and our sample standard deviation is 70.82. This one should be the correct answer. Let's go ahead with example 8. What is most nearly the standard deviation of the previous example data? So if we go down, we can see the standard deviation as a sigma here. Sigma equals to 65.5. This one should be the correct answer. Example 9. The sample coefficient of variation CV of data set 1.5, 1.8, 2.1, 1.7, 2.3 and 1.2 is most nearly. So we have to do the same process here. As you can find in the FE handbook. In page, if I am not mistaken, if page 63, in page 63, the coefficient of variation is defined. The sample coefficient of variation is the ratio of the sample standard deviation S over the sample mean over X bar. So first we have to find the sample standard deviation and also sample mean. So then we can find S over X bar as a CV. So let's continue and work with calculator. So as you can see here, the existing data should be deleted. I am going to enter new data 1.7, 1.8, 2.1, 1.7, 2.3, and finally 1. Same process, second button, statistics, and number 2, and 4. And as you can see here, S6 equals 0.39 and the mean is 1.76. So S equal to 0.39 and sample mean is equal 1.76. So we just need to calculate this 0.39 divided by 1.76. So the answer should be A. That's it. Example 10 is about binomial distribution. The factory produces batches of 20 items. If the probability that any given item is defective is 0.05, what is the most nearly the probability that exactly 3 items in batch will be defective? To solve this example, we can use the binomial probability formula, which is in FE handbook on page 66, and X equals m factorial or x factorial n minus x factorial p to the x q to the n minus x. So here n is the number of trials, x is the number of successes, p is the probability of success, q is probability of failure, that can be 1 minus p. So we can use our calculator to solve this example. I am going to statistics function, so I should press second button, then statistics, then I'm going to select distribution and As you can see here, there are another options also, for example normal distribution, but however we are looking for binomial one. So the right one should be number 4. I'm going to press enter and enter again, and as you can see here, it is asking about trials P and X. We need to provide 3 items here, and also there is data from my previous work, and we can delete or we can change the numbers. Here the N should be 20, X value, X should be 3, and also P should be 5%, 0.05. So I am going to put these values in 20, enter, P 0.05, enter, and the X should be 3. I'm going to press enter again to see the results. As you can see here, the value should be 0.059. It is almost about 0.06, and the A should be the correct answer. Now let's move on to vectors. I've prepared 2 easy examples, as you can see here, examples 11 and 12. Let's start with 11. What is the cross product of vectors A and B? A cross B. A is 2i plus 3j plus 5k. B is I plus 4j plus k. So we can easily use our calc to find the answer. Let's start with that. So I am going to press second button to go to vector options. So as you can see here, there are 3 options: names, mass, and edit. First we should go to edit, enter, and as you can see here, our vectors have 3 dimensions, so I am going to select 3, enter, and I am going to enter numbers into my calc. 2, 3, 5, enter. So I am going to do the same thing for second factor. Now I am going to select V. Previous one was U, its name was U, and this one is V. Enter. The same thing here. One, 4, and again 1. Enter. Now we should press the mass option in vectors. For coming back to that option, we can use clear or we can use quiet button. As you can see here, I am using this button, so I am coming back to vector, mass. Instead of selecting edit, I selected mass, enter. Sorry. I selected mass. As you can see here, there are several options: dot product, cross product. We are looking for cross product, so I am highlighting that and then enter. So we should select our vectors here. Second bottom, vector. Number 1 is U, and remember here we have to use comma between two vectors. Second bottom and this one. Then I am going to select the second vector. Now I am going to press enter to see the answer. So the answer is -17. A or B should be correct. 3 and 5. So the option B should be the right answer. Let's continue with example 12. What is the dot product of AB of vectors A and B in the above example? As you just saw, we put the vectors numbers in our calc, so we can easily use it. Let's come back to the main menu. Second bottom, vector, mass, and number 1 is dot product and number 2 is cross product. We use cross product for this example, and we should use number 1 dot product for this one. The same process. U, comma, I'm going to press enter to see the result. The answer should be 19. As you can see here, we can use our calc easily to find the result. However, let's explain something here. Here we had the matrix numbers in our calc, so we use calc. Otherwise, it is more efficient to find dot product of vectors by hand. You know, if A equals AXI plus AYJ plus AZK, so the dot product should be AX plus AYBY and AZBZ. So for this example, it should be 2 times 1 plus 3 times 4 plus 5 times 1. 2, 12, 2 should be 19, as we can see. So we can easily find the dot product by hand, and we don't need to use our calc because sometimes it can take more time instead of solving with hand. That's it. Keep going. Example 13. What is most nearly the angle between two following vectors? A equals 2i plus 3j and 5k. B is I plus 4j and k. To find the angle between two vectors, as you know, we can use the dot product of vectors. AB equals magnitude A times magnitude B times cosine. Theta is angle between two vectors. So sine theta can be A dot B over magnitude of A times magnitude of B. So theta should be arc cosine AB over AB. So what is the magnitude of A? If A equals AXI plus AYJ plus AZK, so the magnitude of A should be second root of AX squared plus AY squared plus Z squared. So now we can easily use our calculation, even we don't need to write this one, and you can find this formula in your FE handbook. If I am not mistaken, it should be in page 59 in FE handbook, and if you know the formula, we can easily go ahead with our calc. So let's clear this one. So I am going to use arc cosine function or inverse cosine, this button. So I have to press 2 times. So now I am going to use fraction bar, this button, and plug the numbers in formula. So A dot B should be 2 times 1 plus 3 times 4 plus 5 times 1 over, we should use magnitude of A from bottom, and this one second root of two squared plus 3 squared plus 5 squared. Then the second one times the same process, one squared plus 4 squared plus 1 squared. So now I am going to press enter to see the result. So as you can see here, it should be 43.4, and option B should be the correct answer. That's it. Go ahead with matrices. If A is this matrix, what is the inverse of matrix A? We can solve this example by hand calculation, but it can take more time. So let's go ahead and find the answer using our calc. So for solving this example, I am going to press second button, then matrix. So I am going to edit. Now I am going to press number 1. So as you can see here, our matrix is 3 by 3. So I am going to select 3 for rows and the same thing for columns. Okay, and I am going to put the values here: 2, 1, 0, 0, 2, 4, 2, 8. So I'm going to press clear. I'm going to select our matrix. Then I am going to use matrix function by clicking on mass. So as you can see here, number 1 is determinant function, number 2 is transpose, and number 3 is inverse. So we are looking for inverse. So I'm going to press enter and enter. So the answer should be this. So let's check which one is correct one. 0.25, this one, and this one cannot be the answer. This one is minus, and option C should be the correct answer. Thank you. 15. If A is this matrix, what is the determinant of matrix A? So let's go ahead and use our calc to find the answer. I'm going to do the same process. Matrix, edit, three, okay, and I'm going to put the numbers 4, 6, 1, 5, 2, 5, 6, 2, 7. Where? Matrix, mass, number 1. We have to pick up our matrix. Our matrix is A. I'm going to press the enter to see the result. The answer should be minus 16. Thank you. 16. What is most nearly the length of BC in the following triangle? To solve this example, we should use the cosines law. If here is A, and here is B, and here is C, the cosines law say A squared should be equals to B squared plus C squared minus 2B times C times sine A. So A should be second root of this amount. So let's go ahead with our calc. I'm going to use this function, square root, parentheses. To find L, we have to use this one, 310, 200, squared plus 200 squared minus 2 times the same value 200 times cosine this angle. Enter. So as you can see here, the correct answer should be 286. This. Example 17. What is most nearly the theta in the following three angles? As you can see here, example 17 similar to example 16, but here we are asked for the angle, this angle. We again need to use the cosine law. A squares equals b2 c2 minus 2bc times a. So 2bc times a should be b squared plus c squared minus a squared. So cosine a equals and we just need to find the arc cosine. So let's go ahead with calc. I'm going to use arc cosine. (206 squared plus 200 squared minus 247 squared over 2 times 206 times 200. That's it. So the answer should be 74.9. Almost it should be 75 degree. Thank you. Continue with example 18, which is about the division of complex numbers. As you can see here, which of the following is equal to 7 plus 5j over to 3 plus 4j? We can easily use our calcs. However, please note that in calc we are going to use I instead of j as a notation, and it cannot have any effect in the result. So let's go and do by calc. I am going to use fraction key. 7 plus 5. I am going to hit this key 3 times. So 3 plus 4, the same thing. Enter. So our answer is 1.64 minus 0.52i. So this should be the correct answer. That's it. With example 19, what is the most nearly the maximum point of this function between 0 to 2? This is a tricky question because if we substitute the boundary points, I mean 0 and 2, into the function, we will have, let's do that. For 0 it should be 3, for 2 we will have 2 to the power of 3 minus 5 2 squared plus 4 times 2 plus 3, and it should be 8 28, and it should be -1. So in the first look, it seems the correct answer should be this one, but however, we need to find critical points of function by taking the derivative of the function, and then we can find the, for example, the points, critical points, I mean. But however, we have a suitable calculator here, and we can use that to evaluate any function like this. So let's do that. I'm going to put the function into my calc. So I'm going to use table and edit function. I have a function here from my previous work. I can delete it and I can put the new one, as you can see here, to the power of 3 minus 5 x cubed plus 5x plus 3. Enter. The start point should be 0. The step, considering the 0 until 2, we can put 0.1 to see what is the fx values between 0 to 2. I'm going to press the enter to see the result. So for 0 it should be 3, for 0.1 it should be 3.3, for 0.2 it should be 3.6, and it is going to up, and in 0.4 it is 3.8, and in 0.6 it is 3.8, and I think, as you can see also, the maximum is 3.8 because in 1 it is 3, and let's go ahead to make sure the maximum amount is 3.8. So the max, as you can see here, let's check again, the maximum is 3.8. So the correct answer should be option B. That's it. Let's continue to example 20, the last one. What are the roots of the equation minus 6x plus 1x squared plus 3 equals 0? So it is so easy, and actually it is calculator exercise. However, we should be careful because of when we are talking about quadratic equation, we have ax squared plus bx plus c equals 0. So here the a should be 1, not minus 6. I am going to use my calc again. Second button, fully solve this key. So as you can see here, we have quadratic equation in number 1 and cube equation in number 2. So I am going to enter as highlighted. So I am going to assign A, it is 1, B, we should use this one, minus 6, and the C is 3. enter. X1 is 0.55. These are cannot be correct. So the second one 5.44. So this one should be correct. Thank you for watching, and please like and subscribe my channel if you found this video useful.